This is the JSOWC, where a Navy carrier strike group turns precision into punishment. The Houthis never saw it coming, until everything started exploding at once. On March 28, F-18s from the USS Harry S. Truman punched deep into Yemen in a coordinated multi-wave blitz, and all of it was made possible by this new precision weapon. The success of the entire mission hinged on what happened next. At 0440 local time, the first strike package flew low and silent over the Red Sea before breaking off toward their first target, Sana'a. 8 targets had been pre-plotted into their mission systems, and the aircraft split into 2 formations. The first zeroed in on a hardened military headquarters on the outskirts of the city that the Houthis had rebuilt from strikes 2 weeks ago. As this was going on, the second wave launched several more JALCs on pre-identified weapons storage sites concealed among residential blocks. A third target, the Sana'a International Airport, was hit again to demolish patches in the airfield the Houthis had tried to fix. Within 5 minutes, 3 key hubs in the capital lay in smoking ruins, and it wasn't even breakfast yet. The JALC variant itself is a 1,065-pound weapon, stretching 161 inches long with a 13-foot wingspan that deploys after launch. It has the same size characteristics as previous missiles in the JASC family. But what sets it truly apart from the others is this right here. This is a 500-pound Bomb Royal Ordnance Augmented Charge, or Broach warhead. This is part of the secret sauce that makes it better than basically every extended-range air-to-surface missile the U.S. military has had before. However, this isn't the whole story. The Broach is so special because of its 2-stage penetrator, and it works like this. As the missile takes contact with the target, this 50-pound shaped charge in its nose goes off. Inside the nose is a thin metal sheet like this that rapidly caves inward from the massive heat and pressure. As the thin metal sheet melts, the missile's energy forces all of this superheated molten metal onto a single, pinhead-sized point. This mini lava stream is 2.5 times stronger than the one on the classic Blue 109 bunker buster and can penetrate steel, rebar, reinforced concrete, and anything else the Houthis may be trying to hide behind. At a speed of nearly 10 kilometers a second, this molten lava stream can penetrate up to 3 feet of solid steel or 6 feet of reinforced concrete. And once this lava jet pierces that protective bubble, that is where the real damage happens. In just a matter of 5 milliseconds, the 450-pound main charge then follows inside the narrow channel made by the shape charge. Another 1 millisecond delay to ensure the charge is in the hole. It goes off with a vengeance. Anyone standing within 2 meters of the blast site will feel up to 5,000 psi of overpressure, and anyone within 10 meters will feel up to 800 psi of pressure. Experiencing either of these forces would not be survivable, and if that weren't enough, this devastating force would be combined with roughly 4,500 high-velocity steel fragments that could penetrate body armor up to 30 meters away. It's safe to say that anything these missiles hit will be an instant lights out no matter what. By 0700 hours, the jets were rearmed, refueled, and ready for round 2. Amran Governorate, specifically Jabal al-Aswad. Here, there was a communications hub buried more than 20 feet beneath solid rock and thought to contain the encrypted broadcast systems the Houthis were using to coordinate missile salvos. This time around, the formations deployed 4 more JALCs on the underground site. The attack sent shockwaves throughout the area and immediately destroyed all Houthi battlefield communication channels. The targeting was exact, with laser-guided munitions threading into vent shafts, stairwells, and reinforced bunkers. With no time to regroup, the next strike was already underway. Combining this destructive power with a cruise range of over 130 kilometers or 81 miles, the JALC gives the F-18 the freedom to strike from well outside the threat of any Houthi air defenses. And thanks to its high-altitude launch profile, it can glide silently for minutes before slamming into its target with pinpoint accuracy. Once on target, it almost never misses, landing within 10 feet of the bullseye, which makes it a sniper's bullet delivered from a fighter jet. And how it does so is with some incredibly innovative technology. Part of what makes the JASC so special is that it has a triple threat option for guidance systems. The first of these is one you're already probably familiar with: GPS. After launch, the JASC navigates using a blended GPS and inertial navigation system. Its GPS receiver locks onto military-coded satellites to establish its initial flight path. Meanwhile, its onboard inertial navigation system, or short INS, consisting of a ring laser gyroscope with accelerometers, tracks its speed, direction, and orientation even if GPS is jammed. This dual system allows the weapon to fly a pre-programmed course across 81 miles with accuracy to within 10 feet. Even with GPS-denied environments, the INS ensures the JASC doesn't miss the mark by more than 15 feet. With built-in terrain-following algorithms and glide control surfaces, it can adjust its flight path to avoid obstacles and exploit terrain masking, making it extremely hard to intercept. However, this GPS INS setup is already a decades-old system used in conjunction with bunker busters and the whole family of JDAM munitions. It's the combination of these next two alongside GPS that makes the JASC truly unique. It may be hard to see here, but this is the imaging infrared seeker that's at the top of its nose. At about 30 seconds before impact, the JASC activates its seeker. This seeker scans the battlefield below and compares what it sees to an onboard reference image of the target area, which was uploaded pre-launch by mission planners. The resolution of this infrared sensor is so precise that it can distinguish between a truck and a tank, this ship, or even a camouflage bunker by the residual heat from a running generator. If the target has moved slightly, the seeker can automatically correct its aim point and steer into the new location, which allows it to get even closer than 10 feet in accuracy. This gives it a massive advantage over JDAMs, which are blind in the terminal phase and rely entirely on GPS coordinates that may now be stale. By late morning, Sadr came into view. 7 strikes, 1 objective: turn the lights off in the region and cripple every Houthi military installation around it. The F-18s launched these JASCs from near their max release range to avoid the threat of man-portable air defense systems, as the Navy had kicked a hornet's nest that morning and was proceeding to pour gasoline on it. Thanks to their terminal seekers and GPS guidance, these missiles struck within 10 feet of each target. The strike collapsed power stations and severed electrical feeds that powered Houthi radar and surface-to-air missile sites. This was no longer just a show of force. It was a statement that America was going to keep hammering the Houthis until they submitted to a ceasefire. But for now, it was still go time. But this missile is not done yet. It still has one more trick up its sleeve to ensure absolutely nothing the Iranians give the Houthis can ever defeat it. This system is called Link 16. It is an encrypted, jam-resistant data link that allows operators to update the JASC's target mid-flight. Using a secure digital connection, airborne controllers can now send new coordinates, change the aim point, or even reassign the missile to a different target altogether. This is particularly useful when a time-sensitive or high-value target is discovered after launch. The range of the Link 16 is around 300 nautical miles, depending on altitude, and messages are transmitted within 1.5 seconds of initiation. In combat, this means a commander aboard the Truman can redirect an inbound JASC from a collapsing bunker to a mobile command post fleeing the blast zone, all without the pilot ever looping back for another pass. But these pilots wouldn't give the Houthis a second chance anyway. After rearming on board the carrier, the formations went out again that afternoon to Marib Governorate. There, 4 Super Hornets came in low and eliminated 4 Houthi bases they thought were safe. On the way back, the formation dropped bombs at the Houthi naval base at Al Hudaydah and destroyed 3 boat launches and shelters, along with at least a dozen more enemy boats. But this time, after getting back to the carrier, the Truman's air wing would be leaving with something more than just munitions for this next mission. While the US military can certainly do a lot, you can't hit 7 different places on a single tank of gas. Thankfully, the F-18s have their own built-in gas stations. Each F-18 carries around 10,860 pounds of internal fuel distributed across multiple tanks buried within the fuselage and wings. On long-range missions like this one, they can carry up to 3 external tanks, 1 under each wing and 1 centerline. That boosts total capacity by another 8,000 pounds. But that still won't get them to every target and back with enough margin for safety. That's where something known as a buddy pod comes in. If you noticed, some F-18s on this mission aren't loaded with just bombs. If you look here, under their centerline fuselage, you'll see the A42R1 Buddy Store refueling pod. From this, a 30-foot hose trails out the back with a basket at the end. To get fuel, the receiving aircraft lines up behind the tanker jet and extends its refueling probe on the nose and ever so gently makes contact with the basket. Once connected, fuel begins to flow at 1,500 pounds per minute. From the pilot's perspective, it's a ballet at 20,000 feet. Both jets dancing together in tight formation, wings flexing, engines throttling, every movement precise. During this roughly 2 to 5 minute process, the Buddy Store is pulling up to 8,000 pounds of fuel from the donating aircraft's external fuel tanks at a rate of 2,000 pounds per minute. And all of this is happening within 75 feet of each other, going 250 knots. This system extends the F-18's combat radius from around 450 nautical miles to over 700, depending on payload and profile. It allows them to strike deeper, loiter longer, and return safely without relying on Air Force tankers. But it's not without its downsides. Flying as a tanker adds drag, reduces speed, and limits how much ordnance the aircraft can carry. Plus, any mistake during contact could rip off the probe or tear the drogue away entirely. It's a calculated risk, but one the Navy takes because it means this strike goes on. By that evening, the formation had almost reached the Saudi border in Sadr Governorate. 2 F-18s armed with paveways streaked overhead and dropped their payloads on known ammunition depots in the countryside, while the remaining 6 F-18s peeled off for their main target, Hazam City. Here, 12 strikes rocked Hazam City and brought a 4th of July a few months early. 3 Houthi military bases, 2 separate ammo storage sites, and a hardened bunker complex were all destroyed. Without Buddy refueling, none of this would have happened. Not like this, not across this much terrain, and certainly not with this level of sustained tempo. Bye for now.